Hello learners, you're welcome to Dynamic Educational Hub channel. This is a channel where I simplify concepts in physics, chemistry and mathematics for you. And what are we actually learning in today's video? We are actually learning transpose, one of the easiest operation in matrices. Without further delay, let's dive into today's video. What is transpose of matrix? Transposing a matrix means changing the row element into column element, vice versa. Either you change the row element into column element or you change column element to row element. What you are simply doing is you are transposing a matrix. Now, transpose of a matrix, A is denoted by A superscript T. If A is a matrix of order n times n, then A transpose equals to a matrix of order m times n. So what I've done here is I transform the row elements into the column element and the column element into the row element. That's what I've done here. For a better understanding, let's look at the example. If you have a matrix A here, this is the element of A. Now A transpose, we want to change the column here into row. Now all these elements have been written in form of row. Now just look at the direction. Then we have this one going like this and it's been written like this. The same thing like this to like this. So I've transformed the column into row. That is A transpose. The same way, if you transform the row into column, let's see this example, you still get the same thing. You have this and we transform into column. This is written like this, and the last one you write it like this. Let's check all our elements. You see, it's still the same thing. Either you transform the row like this into column, or you transform the column like this into row. You still get the same thing, which simply means you are transposing a matrix. Now, for better understanding of this statement, if A is matrix of order n multiplied by n, then A transpose is equals to a matrix of order n times n. Let's see. Now let's have this matrix B. We can see that it is 2 by 3, 2 rows and 3 columns, 2 by 3. Now if you transpose it, let's see what we are going to get. Now simply we are going to get this, and just picking this and changing it to this, and this is what we are going to get. Either you pick this and you write it this way, or you pick this and you write it this way. If you pick the row like this one you write it like this one you write it like this. At the end of the day, we are going to see that we have seen a matrix of 3 rows. Now I have 3 rows, so 1 row, 2, 1 row, 3, against 2 column 1, 2, from being 2 by 3 to 3 by 2. So that is that about matrix. When you transform a matrix that is a rectangular matrix, the row is going to be switched into the column. It's only square matrix that you still get the same order. 3 by 3, when you transpose it you get 3 by 3. 4 by 4 transpose, you get 4 by 4. But 2 by 3 rectangular matrix, you get 3 by 2. An example, if A is equals to this, you have a matrix here. These are the elements. Find transpose of A. Solution. Now we have our A, B, C, D. And if you transpose it, we're going to get something like this. A, B. Then we have what? C, D. This is A transpose. This is A transpose. And if you carefully observe it very well, you observe that there are 2 elements that still maintain their position. A maintain its position and D maintain its position after we've transposed it. Now, there is a trick in transposing 2 by 2 square matrix. Don't stress yourself. What you just need to do is you just swap this diagonal, the elements in this diagonal, and you swap them. Simple as ABC. Just swapping them, you get your answer. If it is 2 by 2 square matrix, just leave this one and leave the other one. So you pick the diagonal if you move towards the right, from left to your right, the diagonal, if you are moving from left to right, the diagonal, you swap the elements, so you get your answer very fast. That is one trick about transpose of square 2 by 2 square. And let's look at another example. If A is equals to this, and then we are asked to find 2A transpose plus A. 2A transpose plus A. Let's see how to solve that. Now you have your A here. The first thing is to find our A transpose. Don't forget, you change. This time around, you want to change the column into row to get the same. Either row to column or column into row. Look at it. And here, we return this. So we are done. That is A transpose. Now 2A transpose. We all knew that this 2 here is a constant. We want to multiply it with A transpose. That is scalar multiplication. And we use 2 to expand it. If you haven't watched my video on multiplication of matrix, kindly go and watch this video. Now use these 2 to expand this. And obviously this is going to be our answer. 2 multiplied by 0, 0, 2 multiplied by 3, 6, 2 multiplied by 4, 8, 2 multiplied by minus 7, minus 14, 2 multiplied by minus 5, minus 10, 2 multiplied by 36, 2 multiplied by 5, 10, 2 multiplied by 2, 4, 2 multiplied by 1, 2. That is our 2A transpose. Moving to the final question now, which says 2A transpose plus A. Let's write, this is our 2A transpose here, and this is our A in the question. We want to add them together. Let's see how to add them together. Now don't forget, we pick the position 0 plus 0. Then we have minus 14 plus 3. Then we have 10 plus 4. Same thing, 6 minus 7. We have minus 10 plus 5. 4 plus 3. Why are we having minus here is very simple. I've explained several times. We have addition against subtraction. So first times minus, minus. So finally we have 8 plus 5. Then we have 6 plus 2. And then we have 2 plus 1. So now let's solve it. 0 plus 0 will give us 0. Minus 14 plus 3 will give us minus 11. 10 plus 4, 14. 6 minus 7, minus 1. Minus 10, minus 5, minus 15. 4 plus 3 is 7. 8 plus 5, 13. 6 plus 2, 8. 2 plus 1, 3. And that is transpose of matrix. And here we've done transpose and addition operation as well as scalar multiplication of matrix. You can have all these operations, you can have them mixed together in a question. So just follow them and do them bit by bit. As you can see, that transposing a matrix is very easy. You can as well apply this method to any other order of matrix, either 4 by 4, 4 by 3, any form of matrix. You can easily transpose it by changing either the row and you write it as the column, or the column and you write it as the row. And we have come to the end of this video, and before I take my leave, solve the exercise as shown. I have 2 questions here. Solve it, pick the correct answer and comment your correct answer in the comment section. And my next video is going to be on determinants. Thank you. If you haven't subscribed, it is high time for you to subscribe to my channel. Click on the subscription button as shown and click on the notification icon. See you in the next video. Bye for now.